So formula mass is the average mass of a formula. That might be a molecule or it might be a formula unit. In an ionic compound, there aren't any molecules, so it's not really correct to say a molecular mass because there's no molecules. So we call it a formula mass. But it's also known as a molecular mass for molecular compounds, or sometimes a molecular weight, because weight and mass are often used interchangeably. To find the mass of a formula unit or a molecule, you just take the mass of each of the atoms in that formula and you add them together. It's like if you had a box of fruit and it had 3 apples and 2 bananas, and you wanted to know what the mass of the fruit was. Well, it'd be the mass of 3 apples, how much does an apple weigh, and you'd add those together. How much do the bananas weigh? There's 2 of those, so you add those together. It's the very same idea. So, to make it look complicated, we can do this. It's the number of the first element times the atomic mass of the first element, and then you add the number of the second element times the mass of that element, and you just keep going. So let's do an example. Calculate the formula mass of calcium nitrate. So we're going to get some practice writing formulas here. We need the formula before we can write the formula mass. So what kind of compound is this? Ionic, molecular, or acid?
It's ionic.
It's an ionic compound. We recognize it as ionic because the first element is calcium, and calcium is a metal. And nitrogen's a nonmetal. So calcium, when we write formulas for ionic compounds, we're going to take the individual ions. There's going to be 2. So calcium is 1, and the charge on calcium? 2 plus, because it's in group 2A. So that's the calcium, and then nitrate. It's got nitrogen, but it's not just nitrogen, because just nitrogen would be nitride.
Nitrogen and oxygen will charge with the
3. Mm-hmm.
And then the charge of 1.
Yep. So this is one of those that you need to memorize. Okay? Nitrate is NO3 minus because that's what we decided to call it. It's NO3 minus because that's what nature does, and we gave it the name nitrate. So then we look at the charges. This is -1 and +2. Couple of different methods you can figure this out, but when you put it together, we need 1 calcium and 2 nitrate ions. And so we're going to put the NO3 in parentheses because we don't want it to look like we have 1 nitrogen and 32 oxygens. There are 2 nitrate units. So any questions about writing the formula? Okay. Now we can do the formula mass. So in this formula, there's 1 calcium atom, and how many nitrogen atoms? 2. And how many oxygen atoms? 6. Because we have 2 of these groups. So I think of this as being like a tricycle, where you have 1 seat and 3 wheels, right? If you have 2 tricycles, how many wheels are there? There's 6 wheels. Each tricycle has 3 wheels. So we need to be able to look at the formula and identify how many atoms of each element are there. Okay, so calcium, 40.08. So we have 1 calcium atom, 40.08 atomic mass units. And we have 2 nitrogen atoms. Each of those weighs 14.01 atomic mass units. And we have 6 oxygens, and each of those weighs 16.00 atomic mass units. Again, do not round those molar masses to less than 4 significant figures. So 40.08 plus 2 times 14.01 plus 6 times 16, 164.1 atomic mass units. That's what my calculator says. Now, I am not going to be picky with you about sig figs on molar masses. Sometimes you'll end up with an extra one at the end, Because this is adding, it's never going to give you a crazy number of digits, so I think just use all of them, right? Any questions? So, yeah.
So will we have to add a 0 at the end? 164.1.
That's a good question. Should we add a 0 at the end? So we can get nitpicky about significant figures. If you think about multiplying and then adding, when you multiply this one, you're going to have 4 sig figs, 4 sig figs, 4 sig figs. And then depending on how big they are, you may or may not have 2 decimal places, right? If you think about just adding all of these, adding one of these and adding 14.01 twice, and adding 16.00 6 times, just adding, then sig fig rules would say you're going to have 2 decimal places. So I'm okay with either one of these. Okay? When we keep 4 sig figs in our molar masses, that usually will not be the limiting thing for sig figs in our answer. Okay? So it's going to be fine. So that's formula mass. The molar mass for a compound. This isn't the mass of a formula unit. This is the mass of a mole of the compound. So it's the mass in grams of 1 mole of molecules or 1 mole of formula units. And just like with the atomic mass and the molar mass of an element, it's the same number, just a different unit. So it's grams instead of atomic mass units. So let's do this one. What's the molar mass of ammonia? Well, what's the formula for ammonia? NH3. Why? Because I told you. Because it is, right? NH3. This is ammonia, and ammonium is the ion NH4+. Okay, so we're going to calculate this in exactly the same way as we calculate a formula mass. We have 1 nitrogen. There's 1 nitrogen, but now we're talking about moles, right? So let's be just like really, really detailed with the units here. So 1 mole of nitrogen atoms, and nitrogen atoms weigh 14.01 grams per mole, and there are 3 moles of hydrogen atoms in 1 mole of this compound, and hydrogen atoms weigh 1.008 grams per mole. And so you can cancel those guys out. And you end up with 17.034, I think. Let me check that. Yeah. 17.034 grams is what my calculator says. Now, technically, that should only have 4 significant figures, but I think it's a good idea to just leave the 4 on there, okay? Because this molar mass will generally not be the limiting number of sig figs. So this is the mass of 1 mole. So that can be used as a conversion factor. We can say that 1 mole of ammonia is equal to 17.034 grams of ammonia, or we can write it as 17.034 grams per mole. Any questions? So just like we used molar mass to count atoms by weighing, we can use molar mass to count molecules by weighing them. So grams of the compound to moles of the compound to the number of molecules of the compound. So grams to moles, that's the molar mass as a conversion factor. And then here we're going to use Avogadro's number again. So find the number of ibuprofen molecules in a tablet containing 200.0 milligrams of ibuprofen, and there's the chemical formula, C13H18O2. Ibuprofen is my mom answer to every ailment that my children have. I sprained my ankle at football practice. Here, have some ibuprofen, right? It's also sometimes referred to as adult candy, or you've seen the meme, welcome to adulthood, I hope you like ibuprofen. That's not a joke, actually, it's very true. Anyway, so let's look at this question. We can approach this as dimensional analysis. If you're not sure what to do with a problem, I would always give dimensional analysis a try first. It's not always the ultimate answer, but many times it is. So we're given one number in this problem, so let's write it down. 200.0 milligrams. And then we have to figure out, what are they asking us to find? Find the number of molecules. So I'm trying to get to molecules. So I've got milligrams and I've got molecules, and I'm missing some unit in the middle. What goes in the middle most of the time? Moles. Moles in the middle. So if we had moles in there somewhere, can I convert moles to number of molecules? Yeah, that's Avogadro's number. Now the question, how to get from milligrams to moles? Well, we need to put grams in there, right? Because grams to moles, that's the molar mass. And we've learned how to do metric conversions, so we can do milligrams to grams. So we lay out the path that we're going to take, and then we just follow it. So I've got 3 arrows. I'm going to have 3 fractions. Now I returned worksheet 1B and I graded that for you. I want you to pick it up and look at it, okay? Some of you are not quite getting the concept of dimensional analysis. And you can get by with it on regular unit conversions because you can kind of use common sense, but when we get to stoichiometry, which is coming very, very quickly, common sense isn't necessarily going to work so well. Dimensional analysis will work. So we really need to learn this. So 3 arrows, that means 3 fractions. We've got the units there, milligrams to grams to moles to molecules. So milligrams to grams to moles to molecules. Previous unit comes to the bottom so that we can cancel those out. After we have all the units in there, then we go looking for the numbers. You can fill them in whatever order you want, whichever seems easier. This one looks familiar. So I've memorized that milli stands for 10 to the minus 3. I need the numerator and the denominator to be equal to each other. So I've got milli on the bottom. I'm going to write what it means on top. 10 to the minus 3. So 1 milligram is 1 times 10 to the minus 3 grams. Here, moles and grams, that relationship is the molar mass. And I'm thinking, ew, I have to calculate that. Let's go over to this one first. Molecules and moles. Moles is the chemist's dozen. 1 dozen things is 12 things. So 1 mole, 1 chemist's dozen, is that number, Avogadro's number. 6.022 times 10 to the 23rd. Now we have to do the molar mass. So the formula is given. I would encourage you to always show a little bit of work for a molar mass so that you can go back and check your work. Sometimes you come up with the wrong answer. If you've got your work written out, you can go back and find where the mistake was. If you just did it all by punching stuff into your calculator and you come up with the wrong answer, then you have to start all over. Okay? So this is the minimum that I'd like you to show. There's 13 carbons times the mass of carbon and 18 hydrogens times the mass of hydrogen and 2 oxygens times the mass of oxygen. So we've got 13 times 12.01 plus 18 times 1.008 plus 2 times 16. And my calculator is giving me 206.274. Now, I would be willing to argue either way, either 4 sig figs or 5. It's not going to matter up here, though, because this number has 4 sig figs. This one has 4 sig figs. Our answer is going to have 4 sig figs, regardless of what we do with that one, right? So let's just use it as is. What are the units on that number? It's the number of grams in 1 mole of the compound. So that's this many grams per mole of that compound. So we see that the number goes with grams, and so we go up here, and that tells us we're going to put the number in the denominator. And now we have our equation. So 200 times 1 EE minus 3 divided by 206.274 times 6.022 EE 23. And we decided this is going to have 4 significant figures. So 5.838. And let's write down 2 extras. 83 times 10 to the 20th. And that would round to 5.839 times 10 to the 20th molecules. It's always nice to put a box around your answer so that it's easy to find. Any questions? This should be a straightforward problem, okay? Now, for some of you, it might not be. Ask me lots of questions. Ask Chris, your ETC tutor, lots of questions until you get it straight in your head. You're all capable of getting this.